When you flip a light switch or turn on the tap, you're tapping into this giant, invisible world of technology. But what happens when that world comes under attack? Well, today we're going to pull back the curtain on the silent battle for our critical infrastructure. We're talking about the tech that keeps our physical world, running. And look, this isn't some sci-fi movie plot. This is happening right now. This is a real snapshot of recent cyber attacks on critical infrastructure, just in the United States. We're talking water supplies, the energy grid, even the food we eat. The threat is not coming. It's already here. So that's the big question, right? How are they doing this? How are attackers getting into the very systems that control the actual physical machinery of our day-to-day lives? That's exactly what we're about to break down. To really get our heads around these attacks, we first have to understand what exactly is being targeted. And spoiler alert, we're not just talking about your company laptop or some server in a closet. This is about securing the tech that directly controls the physical world. So let me introduce you to the world of operational technology, or just OT. Honestly, the best way to think about OT is like it's the digital nervous system for our physical world. You've got the hardware and software that acts like nerve endings, sensors that detect things like temperature or pressure. And then you have the parts that act like muscles, the motors, the valves, the switches that actually make things happen. It's the critical bridge between the digital and the physical. And this diagram here, it's called the Purdue model, and it kind of shows you how these industrial networks are built. Think of it like a skyscraper. Down at the bottom, on the ground floor, you have the actual physical machines, pumps, sensors, you name it. As you go up, you get to the local control systems. And way up at the top, that's your corporate IT network, the world of email and business apps. Now, for decades, there was a strict wall, an air gap between these worlds. But for efficiency, we started connecting them. And that connection, well, that's the crack that attackers are now slipping through. And the attacks in this world are just different. It's not about stealing your credit card number. It's about causing physical chaos. With a denial of view, they basically blind the operator. Imagine trying to run a power plant when all your screens go blank. Then there's denial of control, where they actually hijack the system, stopping you from shutting down a machine that's about to fail. And a denial of service can just shut down the whole control network, leaving these critical systems to run completely wild. So because the consequences here are so real, so physical, it's finally gotten the attention of governments all over the world. The old days of treating industrial security like some kind of optional extra, yeah, those are officially over. This number right here, it says it all. 10 million euros. That's the fine, the potential fine, for not complying with Europe's new NIS2 directive. Or, get this, 2% of your company's entire global revenue, whichever is higher. All of a sudden, security isn't just a good idea, it's a massive, high-stakes business requirement. NIS2 is basically a global call to action. It forces these critical companies to get serious and build a real security program. It's all built around these 5 key pillars you see here. It starts with asset management. You gotta know what you have. Then access control. Who can do what? Network segmentation to wall off threats. Logging and monitoring to see what's happening. And of course, continuous risk assessment. It's a full circle, no excuses approach to defense. Okay, so theory is great. But how do you actually do all this? How do you defend these incredibly unique and complex networks? Well, it takes a whole new generation of technology that was built for this specific job. Let's start with the network itself, the foundation. For years, we relied on these rigid, old-school network connections. They were complex, you couldn't really see what was going on, and security was usually just something you tried to bolt on afterward. The modern way is called secure SD-WAN. Think of it as a smart, flexible network that you can manage from one spot with security baked in from the very start. And hey, this isn't just a sales pitch. The data actually backs it up. In a deep dive risk analysis of 9 different network technologies, secure SD-WAN came out on top with the lowest risk score of them all. That little number, 0.3522, shows just how much more effective it is at defending these critical environments compared to the old way of doing things. But it's not about just one tool. Modern defense is all about creating an integrated platform, something we call a security fabric. Think of it like a unified command center where all your different security tools are constantly talking to each other, sharing intel, and working as a team. This big picture view is exactly what you need to handle something as complex as the NIS2 regulation. So let's see how this actually works, starting with that first pillar of NIS2, asset management. It's a simple idea, right? You can't protect what you can't see. A platform like this gives operators a live, complete inventory of every single device on their network. It's step one, the foundation for everything else. All right, next up is access control. Now this is where it gets really powerful. Modern tools can actually understand the specific languages that these industrial machines speak. That means security teams can set rules for not just who connects, but for what they can do. So for example, you could let a technician read a pressure gauge, but block them from actually changing the pressure setting. That kind of granular control is an absolute game changer for safety. And finally, all of this information, all this intelligence, it all comes together right here in a logging and monitoring dashboard. This gives operators that single pane of glass they need to see everything happening across the entire network. They can see the top threats, where they're coming from, and drill right down to investigate. When something bad happens, this is the command center you need for a fast, smart response. So, the tools are there. The strategy is clear. But building this kind of digital fortress, well, it's not a one-and-done project. It's an ongoing battle. And this might be the most crucial takeaway of all. The tech is amazing. It's an enabler, but it's not a magic wand. Real security, real compliance, it takes a combination of people, processes, and technology. You need the budget to do it right, you need people who are trained to handle these unique environments, and you need processes that can actually last. Which kind of leaves us with this one big question, doesn't it? As our world gets smarter and more connected, from our power grids to our cars, we're creating amazing new things. But are we also building a more fragile world? Securing our physical reality is one of the defining challenges of our time. And honestly, it's a battle we simply can't afford to lose.